Hi, and welcome to our next Level 2 Networks video. This video is all about minimum spanning trees. A minimum spanning tree is basically a tree or a mathematical diagram which connects all the nodes, where the sum of the lengths or the times or the costs, etc. is a minimum. Here's an example of a minimum spanning tree, and we'll show you the example on how to do this. Right, straight to the example. A network of internet cables is being planned between 7 suburbs. Shown is a network of the costs for each cable. Determine the minimum spanning tree to allow us to determine the minimum cost to connect all suburbs to the internet. So we have 7 suburbs, A, B, C, D, E, F, and G. And they've all been connected by cables. Actually, not all of them. We haven't got a cable between suburb G and suburb D. So not every suburb connects to every other suburb. If we were to put a cable between A and B, it's going to cost us $5,000. Now, something to note that the way I've drawn the diagram, these two cables look to be the same length. But again, they represent different costs. Just like the last example, if you watch the video, one of them could be really hard ground or really difficult terrain, or maybe going over water. And so therefore, maybe the $11,000 cost is a lot more expensive than the $3,000. So don't get fooled into thinking that the same lengths represent the same costs. Right, we're going to basically turn it into this. This is called the minimum spanning tree, and I'll show you how to do this. Okay, we're going to start basically by starting with the lowest cost. Now, in this example, there happens to be 2 cables which are the lowest, and it doesn't really matter which one to pick to start with. So I'm just going to pick between nodes F and G. So I'm going to highlight that, and it's often good to have a highlighter and highlight that on your page. And I'm going to colour in node F and colour in node G. So I've now connected nodes suburb F to suburb G. All right, well, I'm going to move to the next minimum cost, which is the other $3,000. So I might as well do them both. And I'm going to connect suburb E to suburb C. So I've connected those 2 suburbs and used up that $3,000. Right, let's turn our attention to the next lowest costs. Again, we happen to have 2. So I'm just going to pick one of these, and I'm going to pick connecting suburb G up to suburb B. So now G and B are connected. So therefore, B, G, and F are all connected. The next lowest cost is the other 5,000. So I'm going to now connect suburb B to suburb A with that $5,000 cable. And now suburbs A, B, G, and F are all connected. Suburbs C and E are connected, but they're separate. They're not connected to the other 4 yet. Right, well, let's keep going with finding the minimum costs. So let's keep going. Well, there's a $7,000 cable, and that's good because now that connects suburb G to suburb E, which is good because now suburbs A, B, G, F, E, and C are all connected. Now, if we keep going and looking for the lowest cost, you'd see that these are the next lowest cost, but I don't need to use these cables because I've already connected A, B, C, E, F, and G all together. The only suburb that's not connected is suburb D. So let's now forget about the 9,000 and turn our attention to suburb D. There's only 2 cables I could use, 11,000 or 15, and the one I want to use is the 11,000, which is the cheapest, the minimum. So that connects C to D. So there is my minimum spanning tree. It connects all suburbs together with the least amount of cost. So all I need to do now is add up those numbers there on the minimum spanning tree, and I can now answer the problem. The minimum cost to connect all suburbs or all nodes is $34,000. Right, well, that's us for this video, so thanks very much for tuning in.